Thank you, Leon. My name is Schnorr. I was part of the Swagger Labs ethylene sensing team, and I'm now CTO of our newly founded startup, C2Sense. Just imagine you want to make a nice guacamole for some friends. What you need is a ripe avocado, and that's not always as easy as it should be. So what you can do when you realize you bought one that needs a few more days than you have to get ripe is you put it in a paper bag together with an apple, and after a few days you take it out and it's ready. The molecule responsible for that is called ethylene. It's a small molecule that's given off by fruit while it ripens, and it also induces ripening of fruit. So you can use that for several interesting things. You can remove ethylene to extend the shelf life of produce. So here on the left you see an industrial scale ethylene scrubber, but there are even things that you can buy at Whole Foods or at other supermarkets that you can put in your fruit bowl to make sure things last longer. You can also get a ripeness estimate by monitoring ethylene. You see a spike when things get to peak ripeness. So by measuring that, you get a lot of very useful information. Why do we care about ripeness? Ripeness matters because many times things get too ripe and they spoil. And worldwide we have about 1.3 billion tons of food waste every year, and about 8 to 15% of that is due to spoilage. So it's a huge problem, and what we have to do is become smarter about how we handle that. One solution is to put in sensors to enable new capabilities, better supply chain management. You can have sensors in supermarkets for ethylene monitoring, ethylene scrubbing, to have better quality and longer shelf life. You can use ethylene monitors in shipping and storage to know if you ship something to Iceland or to New York because it only has a week left until it needs to be sold. You can use these sensors at receiving docks to see if something is ready. Or you can even use an ethylene alarm. Flowers are very sensitive to ethylene emissions. Sometimes you place the flowers next to your produce department, so you want to be alerted when ethylene levels peak and would spoil your flowers. Currently, the problem is that there are no good solutions to measure ethylene. You can use gas chromatography or electrochemical sensors, but all these solutions are way too expensive for the food industry. So what we need are better sensors. They have to be inexpensive. They should be small, consume low power, so it's easy to combine them with solar cells or even passive systems. And it's important that they can be made in a very simple fashion. If you want to make something simple, why not have simple technology? What we do is we take two electrodes, we put our sensing material in between, we apply voltage, and we measure the current. When ethylene is present, that current changes. So we can have a very direct measurement about how much ethylene is next to our sensor. To get there, we have developed an ethylene sensing material that interacts with it, that helps us get the selectivity for this molecule that we need, and we've developed a fabrication method. So to show you how simple it is, here this part that looks like a pencil is basically our compressed sensor material. And all it takes is to draw this material between the two electrodes we have there, and this gives our sensor chip the core element of our sensor. Now all we have to do is we take this chip, combine it with commercially available electronics, very simple, and we have a complete system. Could be something, a wireless system that you put in a warehouse or in a shipping container that sends data to your cell phone or to an automated control system. With these sensors, you can do a lot of new things all across the food value chain. You can use it in pre-harvest to decide when to pick, let's say, a melon in the field. You can use it in shipping or in warehousing for smarter supply chain management. You can use it in retail to offer higher quality, optimally ripe fruit to your customers. And you could even have it in your refrigerator. One day, the refrigerator that sends you a text message to take the tomatoes out today or tomorrow before they go bad. But it doesn't have to stop at ethylene. It doesn't have to stop in food and agriculture. You can modify these sensors quite easily to make something that's important for worker safety, for the oil and gas industry, or later down the road for intelligent buildings or even smart cities where a lot of things are connected through these sensing systems. To commercialize that technology, we've just launched our company C2Sense that has a goal to bring low-cost, chemi-resistive sensors to food and agriculture. We are currently supported by an NSF SBIR grant to have a 3-person R&D team over in Brighton. Our goal is to get to field-testable prototypes in the course of the year. And getting there, we've had a lot of help by the Deshpande Center and our catalyst, Hemang Dave. So I'd like to thank you for getting us to this point, and looking forward to seeing where the road will take us. So thank you very much for your attention, and I'd be happy to show you more at our poster.